Okay, my YouTube people, this is a video on tips and tricks for your 4-speed. I did a full build video and that's already on my channel, and I'll put a link to that at the end. But this is more of specific tips and tricks to help you along with the 4-speed. Please don't forget to like and subscribe, and thanks for hanging out and watching this. Now this 4-speed is for a 49 pan head, and you can see it by M is 12 and 8. This was built in December of 48, which would be for a 49. And I already glip-talled the inside of the case with the paint, and then liquid Teflon right where the studs come through. On this one of the studs was stripped out, and they do sell a stud that's bigger on the aluminum end, so you just tap it out and then you're able to put the bigger stud in. For the next size up stud, I'll put the part number in the description. So the first critical measurement when you're rebuilding one of these transmissions, you make sure that your main drive gear has the right clearance, and the way to adjust the clearance is with different size bearings. Okay, the tools you'll need for this job is a 0 to 1 inch mic, a 1 inch to 2 inch micrometer. You'll need a bore gauge that can go out to 2 inches. You need a 1 to 2 inch bore gauge. You need a 3/4 to 1 1/4 bore gauge. And you can also do this with a vernier caliper, but it's not as accurate, but it can get you close if you're in a jam. You'll also need a piece of paper to write down your measurements. Is figure out the inside diameter of it. The best way to do this would be with a dial bore gauge, but I don't have that and it's really expensive. The other way you could do it is with an inside mic. And the way these work is you turn this knob loose and you push the ends in. Once I have the ends snugged up, I just rock it in the bore like that. You can feel where it's tight. After that, you take a micrometer and mic that bore gauge. You see what it is. To read it, it's 8, and then 3 lines is 75 plus 5. So it's 0.880. So you want to make sure to write that down. It's the main bearing, outside race. The inner diameter is 0.8805. For this one, I needed a new 4th gear. So the main drive gear is Andrews 061990. This is where the bearings ride on here, and you want to mic this surface. This does have a little bit of a film coating. I'm going to make sure that I just give it a little scrape to make sure that coating's off. And there it is. And this is at 0.6. One line's 25 and 4 makes it 29. That's 0.629. So you want to write that down. Main gear, outside diameter, 0.629. Now one thing I want to show you is you can use a vernier caliper if you don't have the bore gauges. It's just not quite as accurate, but it is pretty accurate. I'm at 880. Right there, 880. Then you can take your gear, come here and measure it, and you're at 629 right here like that. So it's pretty accurate that way also. The next thing you want to do is you want to mic your bearings. And these bearings are at 123. Now stock, they're 125. So you want to write that down. Needle bearings, 0.123. The formula for this is main bearing outside race, ID. Subtract it from the main drive gear, OD. Then you take your needle bearings times 2, and then you subtract these two numbers, and that equals your clearance. So let's do that real quick. It's going to be 0.8805. Subtract it from 0.629 is equal to 0.2515 minus the bearing diameter is 0.123 times 2 is equal to 0.246. Now you subtract those two numbers. 0.2515 minus 0.246 is equal to 0.0055. That's 5.5 thousandths of clearance. The factory recommended clearance on this is 0.5 thousandths to 2 thousandths. The standard needle bearings measure 0.125 when they're brand new. So now if we were to put standard needle bearings in here, you would have these two numbers subtracted are still 0.2515, and now this is going to, at 125 twice is 250. So now if you do that math, it's 0.2515 minus 0.250 is equal to 1.5 thousandths. And that gets you within the spec of 1/2 to 2 thousandths. So if you put standard needle bearings back in this, you'll be right where you need to be. Now I already did this math and bought a pack of standard roller bearings. There's 88 that comes in a pack. I'm just going to put 44 on this and reinstall it. And that's the proper way to figure out the bearing clearances for a 4-speed main gear. The other bearing clearance you have to figure out is this bearing clearance here on the gear cluster. And I'm going to do that and show you the math on that. Next, we'll grab our smaller mic. We'll get the inner diameter on this. Again, I cock it and I snug it up and I bring it through here. Now I take my 1-inch mic, check this. I check it, I come up with 1 inch and 6 thousandths. It's 1.006. We'll write that down. There it is. Now the shaft diameter. So that measurement is 0.755. So now if we do the math using the standard bearing size, which is 0.125, and double that is 0.250, it's 1.006 minus 0.755 is equal to, now you subtract the bearings doubled, minus 0.250 is equal to 1 thousandths clearance. So on this one you can go back with standard bearings and you'd be fine. And that's what I'm going to do on the gear cluster on the counter shaft. I did have to buy 4th gear, which is Andrews 061009. Also had to buy a new counter shaft, which is Andrews part number 027650. You can see that Andrews made a few improvements with these gears, changed them up quite a bit. This made it a lot stronger, having all this beef in here rather than this. So the first thing I'm going to do is take this coating off and then install the seal. Now I just went over it with a little brake clean and took that grease, that spray grease that they put on it off. Okay, I got the seal in, and I learned from the last time I did this, I used a lot of assembly lube to use petroleum jelly to do this. And I just got an inexpensive brand. A transmission shop that does manual transmission recommended this. You don't want to use grease because grease won't melt. This stuff melts at a very low temperature, so it's good to use to hold the needle bearings. And then it'll melt right into the oil. And once the transmission gets hot and I take it for a little ride, I'll dump that oil and change it out and go with a full synthetic oil. Okay, now I got the 44 bearings stacked in there. I'm going to put a little extra of the Vaseline on them. Okay, to get this in here, you stand it up like this. Set that gear in there. So on this 49 pan trans, I had to put a new main shaft in. I went with Andrews. It's part number 208500. Also put a new main shaft bearing in. It's Torrington. And the part number is 305 PP. This is with the gear cluster installed and the new main bearing. Now I'm going to assemble this into the transmission. One thing I wanted to point out is this is the 58 and up gear cluster along with the 58 and up 3rd gear. And this is Andrews aftermarket, and this came in the trans when I got it. The way this is installed is the gear goes on, then the tooth spacer and the lock ring. With the later gear set, it has a much deeper shoulder in here to give it more stability this way. Also, the gear cluster has a much deeper pocket to fit that extended gear. Like that. You can't interchange this with early and late. Now I have the main shaft and all the gears installed for the main shaft into the transmission, and it's a new Andrews Products main shaft. This is good for 37 to 64, and it's Andrews part number 208500. The next thing I'm going to do is install the transmission main drive gear spacer that goes in here, and I use this V-twin spacer. It's V-twin part number 17-0392. This is good from 37 to 48 ULs, 37 to 40 ELs, and 41 to 1976 FLs. Also 71 to 76 FXs. The OEM part number on this is 35171-37. This is drive spacer here, but the good thing about this drive spacer is has this groove cut in it. You put this O-ring in it. It seals, this O-ring seals oil in back on fourth gear. This is not original like this. And to install it, you just put it here. You just work it around in like that. And there you can see that O-ring installed. There's somebody that sells these on eBay and they ask a really high price on them. This one was very reasonable from V-Twin. And this is a really good trick to keep oil and not to have a leak out of fourth gear. I'm going to just put a little bit of Vaseline down in here on this. Make sure to Vaseline this O-ring so you don't cut it while you're installing it. And just to make sure I don't cut that seal when I'm putting it in, I'm going to put a little layer of tape around the threads because they can be sharp. Okay, you can see the tapes around it. Okay, now you just slip it on. Okay, in the last clip, I'm sure you saw that I was having problems getting this spacer on the... I ended up having to have a friend chuck this up in a lathe and take about a thousandth of an inch out of the center of this with a piece of emery on his finger. And now you can see it slides on nice and easy. It's just about a thousandth. So if you're going to buy this spacer with the O-ring, it would be wise to know that and have access to a way of getting about a thousandth out of here. Either that or think about that before you buy this piece. So now I put the O-ring back in. Okay, now I got the O-ring in and I got it Vaselined up pretty good. Now I'll put the bearings in and reinstall fourth gear. Get the bearings in, I'm going to put the backing washer in first. And then I'm going to stack the bearings in here. I have plenty of Vaseline on these bearings. And now I'm going to stack the bearings in here like this. And the Vaseline holds everything in place. Now that I have the 44 of them stacked in there, I like to give it an extra coat of the Vaseline just to make sure they stay while I'm putting fourth gear in. Now I'm going to slip fourth gear up in here. Like that. Just like that. And make sure I push the bearings back down where they belong. Now I'm going to slip the race back on. Now I'm going to take the tape off of here and then use the sprocket and the sprocket nut to push that spacer in the remainder. So this is like a week later. I had to remove the seal out of here because for some reason when I put the spacer in the seal, it popped the lip of the seal inside out. So I decided to put the spacer into the seal first and then I'm going to install the seal. Before I install this seal, I put a little bit of RTV around the outside edge and then install it. So I'll check back in after I get it fully installed. So you can see I got the seal in and the spacer in and the lip's not all bulged out on the seal like it was the last time. Also you can see I only had the high temperature orange RTV which I used. It's no big deal, you won't see that because the sprocket covers this whole area. So that's what I had. I'm going to put fourth gear back in and I already have the roller bearings installed. Okay, now that I have the main shaft in and had to do that about 5 times, I'm going to put the countershaft in. And the first thing you have to do is put this cluster gear in. This piece here is for the speedometer. So I put a little grease down in there, gets a washer in. And then the needle bearings. And then it gets this bigger washer on this side. Same with the other side. There's a clip down in here you can see, possibly. They both have that clip. And then they get one of these flat washers, then the needle bearings. On this side, it gets a washer that's a shim. So you have to put it together and then check your end play. After you check your end play, if it needs an adjustment, you just adjust it. And I'll show that. So now you can see I have the 22 needle bearings in on this side. Then I like to take a good amount of Vaseline and paste over them and that'll hold them there while you're putting the counter shaft in. Let's do something like that and get some up on the top, and you can see they're not going anywhere. Now you just put this washer on, and I'll just put a little more Vaseline up on this side to hold everything, and that's what it should look like. Now do the other side. First I'll Vaseline it up real good, then this washer, then 22 needle bearings, and then I'll install it. So I want to go over how to check the end play on the counter shaft, and you can see this one has a good bit of end play, and I already have the shim in it. If you go into the manual, the shims for this come in 74 thousandths, 78, 82, 85, 90, 95, and a tenth of an inch, or 100 thousandths of an inch. This one has the 100 thousandths shim in it. This one has the 100 thousandths shim in it, and the end play per the manual is 4 thousandths to 12 thousandths. Now I take down in here, and this is a 16 thousandths feeler gauge, and I put it down in there, and it's snug. This one's at 16 thousandths, and it has the biggest shim in it. Now I'm going to show you the cause of this. So here's that 100 thousandths shim, and they don't make one bigger than this. What happens is you have a steel insert, which is essentially a bushing that the counter shaft goes through, and you can see there's 2 oil grooves in this, and these will wear. They'll wear right there. These have to be pressed out, and then a new one pressed in. Then they have to be a line honed to get them straight, and that's a lot of work that I don't want to get into, and I don't want a chance with ruining this transmission. So what I did is I got 2 thinner shims, and I had them surface ground. So my feeler gauge was at 16 thousandths. It needs to be 4 to 12 thousandths. So I needed to tighten it up 10 thousandths more, and that would put me at 6 thousandths end play. So I got 2 of these. I had them surface ground, and now that one's at 55. This one's at 55. So when I put them together, they're 110, 111 thousandths. So I'm going to put this in there so I don't have to get into pushing these bushings out. I happen to have a friend that has a surface grinder, and he did these for me. But you could go to any local machine shop, and they would have a surface grinder to thin these out. These started out 74 thousandths, and I had them both taken down equal amount, and now they're right where I want them. And I'll install these and show you where we're at on the end play. I go in there with 4 thousandths, no problem. Now we'll try 5. 5 goes in. It's definitely snug at this point. 5 goes in. Now we'll try 6. 6 goes in, but it's pretty tight. So we're right about 5.5 thousandths. How you can get away with doing this without having to do those side bushings. You can see now it's got very little end play. It doesn't clunk back and forth like it was. So the next thing I'm going to address is the shift forks. You can see these have heavy grooves in them. You also want to put a straight edge across here, make sure that they're not bent, and then you want to check in here. You want to see the wear here. Now you can see these got a pretty good groove in them, so they're bad. I bought New Andrews shift forks for this. The drag number is DS 194-210, and the Andrews part number is 209-750. That's for the one fork. The other fork is Drag Specialties. This is DS 194-200, and the Andrews number is 209-760. These come with some kind of like grease on them to stop them from rusting. I just take a little brake clean and take that off. So there they are. And now I'm going to assemble it with the shims the way they originally came. This part's keyed. It goes in this groove. It just sets right back in there. Then you put the fat shim in. Then there's 4 of these thin shims. I'll put those on. Then the shift fork went on like this. Now there were 2 more thin shims. Then the lock. And then the nut. I'll tighten this one down after I do the other one. There's the other shift fork, and you can see it. Not only is it worn, but it even has a burn mark on it right there. And it's really got a heavy wear mark right there. Okay, again, the assembly goes like this. Now it's back together. Now I'll show you how to adjust the shims if they need it. Of course, you got to put 2 new rollers on the fingers. First you install the shift fork pin. Then you kind of get the shifter clutches centered. Put the lid on with the lid in neutral. And you see that just fell right on. I've been very successful just eyeballing the shift forks and getting them close. Proper way to do it is with this jig. The first thing you do is put the transmission into fourth gear. And you can see you have this long straight piece here. Bring the alignment jig up, and then this pin should go through and sit into that groove. And if it doesn't sit quite right, you just loosen it a little. Get it in there the way it's supposed to be. That. And then you tighten the thumb screw down. Now once you have that one set, you take and put the transmission in the third gear. And you have this long straight section on the drum. And it's the same thing over here. You set the pin down in so that it sits in there flat like that. And then you tighten the thumb screw. And now your two blocks are aligned. You bring it over to the transmission. You have to make sure the rollers are on the forks. Then you take this and you set this on here like this. Fork rollers are centered in there like that. Now what you have to do is you have to take, while this is setting in here and it's holding the forks steady, you have to take a feeler gauge in here and measure on each side of the shifter clutch and the gear dogs. And you have to make sure that they're pushed out all the way on both of them. So I have my feeler gauges set at 110 right now, and we'll see if it fits at all. And it doesn't on this side, doesn't fit in either side. Now I have them set at 100 thousandths. It was about 90 thousandths on this side, and it's 82 thousandths on this side. They make these shims in 7 and 14 thousandths thickness. So this one has to be moved 4 thousandths over towards first gear. We'll check the other side and then we'll decide on what we have to do. So on fourth gear it's 100 thousandths on, and the third gear side is, and the third gear side's 100 thousandths also. So the third and fourth gear shift fork doesn't need to be shimmed. So I'm going to just check the thickness of all these shims and see if I have one thin enough that would move it closer. So this is a 7 thousandths shim. So it was 82 here and 90 here, and I'm trying to move it over towards first a little bit. So we'll put this on the back side of the fork and then recheck it. And to do that, we just pull off the shift fork, put this shim on there, put the shift fork back on, put a couple of these shims back on, we'll put the lock on, and then put the nut on. The nut has this dish in it, so it's important that you have some shims here to make sure that the nut bottoms out. You don't have to over tighten it, hand tight's pretty good. Put it back on, let's put that in, put the test fixture back on, and now we'll check to see where it is. Okay, that's 82 now on this side, and now we'll check the other side. And now the other side's 82. Now both sides are at 82, and I'm going to leave that there. And that's how it is you shim these up. Now we'll just tighten the nut up and then bend the locking tab over, but I'm also going to put some blue Loctite on these just in case. Now we're at the point of putting the sprocket on. You have to remember to put this key in. There's a notch in that spacer, and then it goes into one of the grooves of fourth gear. And it sets in just like that. Then the sprocket and this side goes facing in. The next thing that's important on any of these 4-speeds is the James Gasket Supernut. And the part number for the Supernut is JGI-35211-36-DL. And that's used on 1936 to 1986 4-speeds. I know it says on the package here 1970, but they go all the way back to 36. And this is the difference between the stock nut and the Supernut. You can see the Supernut has a seal that goes inside of it, and it helps keep the oil inside of the seal. And one of the things it tells you to do in the instructions is to put a little RTV on both sides of your transmission sprocket, and also a little bit on this flat surface on the Supernut. So I'm going to do that now. Okay, that's the complete installation of the Supernut and I went with a 24 tooth sprocket on this one. Give it a try. So thank you for watching. Please like and subscribe.